In this video, I'm going over the concept of, with our differential equations, finding those solutions, but focusing on that particular solution. So what that means is whenever we have plus C, this refers to the general solution. So that means to find the particular solution, we're going to actually solve for what is C. Now here to go through this process of solving a differential equation. Now we're going to focus on passing through the specific point here. So like for example, we have our differential equation of 4x plus 2, right? That's equal to our dy dx. So we're saying like this is our derivative going through the point 1, -3. So we're looking for what is the particular solution that has that derivative here, right? So well, if you think about it going through the process, we need to know what is y. Well, right now I've got dy dx here. Well, if dy is being divided by dx, then I'll go through and multiply, right? Both sides by dx. So here, that means I've got dy is equal to 4x plus 2, right? Times dx. So now, here, the opposite, right, of our derivative is the antiderivative. So I'm going to go through now and we can find our integral, right, the antiderivative of both sides. Now keep in mind, this is not just dy, right, this is 1 here. So 1 with respect to y. So what's the integral of 1? Well, because this is with respect to y, this is just y. That's how we're getting what y is equal to. Then here now we go with our integral, but now with respect to x, which is 2x squared plus 2x plus c. Now, this is the general solution, right? But remember, we're going to focus on the particular solution. So how are we going to do that? That's where the point comes in. This is your x and this is your y coordinate. So that means, what are we going to substitute for y? -3. So -3 is equal to, and what are we going to substitute for x? 1. So 2 times 1 squared plus 2 times 1 plus c. Now simplify. So here I've got -3 is equal to, so 2 plus 2 is 4. So here, notice, what does our c have to be here to get us -3? Well, if you want to go through and subtract 4, that's fine. But c is -7. That is our particular solution. Y is equal to 2x squared plus 2x plus, oops, sorry, not plus, minus 7. That is the particular solution where if we get the derivative of this here, it would be 4x plus 2 going through that point 1, -3. So here, let's do this one. So again, we're going to find the particular solution. Now notice it's just a different format, but same thing. This is like saying our f of x, y of x. So that means this is the same as saying we're going through the point, given the point 1, 2. So here we go. So again, we're going to find dy, which is equal to 3 plus 6x squared with respect to x, right, dx. So again, we're going to find that antiderivative, which is y is equal to 3x plus 2x cubed plus c. And again, right, remember, that is the general. Now we're going to go through and find c. And how do we do that? Plug in our x and y. So what is y? 2. That is our y coordinate. What is x? 1, because that is the x coordinate, plus c. Now go through and simplify. So 2 is equal to, so that's just 3 plus 2, which is 5, plus c. So what is our c equal to in this case to get us to 2? -3, right? 5 minus 3 is equal to 2. That is the particular solution. Y is equal to, here, I'll write my answer. Let me do that. I'll write my answer in standard form. So 2x cubed plus 3x minus 3. That is the particular solution. So here, pause the video and try this one on your own. Find the particular solution given our differential equation here. And here we go. So again, you're going to find the integral here of dy, and then here 8x minus 5 with respect to x. So that means y is equal to 4x squared minus 5x plus c. And here you had to substitute y with 2 and x with 0. And then notice here, that's just 2 is equal to 0 plus c. So that means c must be 2. So here, the particular solution is 4x squared minus 5x plus 2. So let's continue on to some other types here. Now notice in our differential equation, so here notice we'll be finding the integral, right? So y is equal to, but now notice to find the integral here, right, with respect to x, we're going to have to use u substitution. So u in this case is 3x. So here we go. du is equal to 3 times dx. So now we divide by 3. So that means here we've got dx is equal to 1/3 times our du here. So notice here that after taking 1/3 of 9, we're now down to the integral of 3 times e to the u minus 1, right? Then again, with respect to u. And so here we end up with y is equal to 3 times e to the u, which is 3x minus x plus c. But again, we're looking for the particular solution. So here we go. We're going to now substitute y with 7, which is equal to x is 0. So 3 times e to the 3 times 0 power minus 0 plus c. Now notice this is just 3 times e to the 0 power, right? Well, notice when you put it in the calculator, you just get 3, right? Because e to the 0 is 1. So 7 is equal to 3 minus 0, which is just 3. So that means here, what is our constant in this case? 4. So our particular solution is y is equal to 3 times e to the 3x minus x plus 4. So then here, notice when we get our integral, right, with respect to x, we're at y is equal to. Now notice, here we go. We're going to have to use u substitution of 3x minus 2. So our derivative here is 3 times dx. So again, divide by 3. So notice again, we've got that 1/3 times du. Well, 12 divided by 3, right, is 4. So we're going to find our integral of 4 over u with respect to u. So again, notice that's our special case, right? So this is y is equal to 4 times the natural log of 3x minus 2, right? That was our u, plus c. But again, we're looking for the particular solution. So again, we substitute y with -3, right? That was your y coordinate. Then is equal to 4 times the natural log of 3 times 1 minus 2 plus c. Now notice by simplifying here, right? We've got -3 is equal to 4 times the natural log of 1 plus c. Well, natural log of 1 is 0. So, and 4 times 0 is 0. So -3 is equal to 0 plus c. So that means what does c have to be? -3. So that's our particular solution. Y is equal to 4 times the natural log of 3x minus 2 minus 3. That is the particular solution. So here, pause the video and try these two problems on your own. And here we go. So again, here you should have gotten here with our integral, right, with respect to x. You had to use u substitution. U was equal to 2x, and the derivative du is now equal to 2 times dx. So after dividing by 2, right, and 6 divided by 2 is 3, you end up taking the integral of dy, which is equal to the integral of 3 times e to the u, right, because that was your 2x, minus, and then here, integral of 4x dx. So here, we'll take those separate integrals here. I'm sorry, I realized I didn't show that. I apologize on the earlier problem. I realized we were supposed to separate here. Sorry about that. And then, so this is with respect to u, but here this is with respect to x. So again, just keeping in mind if we have that separate term here. So here we go. So that means here we've got y is equal to, so that is 3 times e to the u, which is 2x, minus, then with respect to x, which is 2x squared plus c. So now, finding our particular solution, y is negative 2, and 3 times e to the 2 times 0, which is actually just 0. So again, that's nice here. Minus 2 times 0 squared plus c. So negative 2 is equal to, you should have gotten just 3 plus c, making c equal to negative 5. So y is equal to 3 times e to the 2x minus 2x squared minus 5. So then here, you also had to notice when getting the antiderivative here, right, that you end up with, again, u substitution of 2x minus 5. So du is equal to 2 times dx, divide by 2. So 1/2 here, well, 1/2 of 4 is 2. So we're going to find the integral, right, of dy on here, and the integral of 2 over u with respect to u. So that means here y is equal to 2 times the natural log of u, which is 2x minus 5 plus c. So then here y is 3, which is equal to 2 times the natural log of 2 times 2. Oh, wait, hold on. Sorry, I realized that was a typo. I apologize. X was supposed to be 4 here. There we go. So that means here 2 times 4 minus 5 plus c, which gives me 3, which is equal to 2 times the natural log of 8 minus 5, which is 3 plus c. So now 2 times the natural log here of 3. I'll round that to the nearest thousand, so 2.197 plus c. So now when you subtract, you end up with c, which is 0.803. So here y is equal to 2 times the natural log of 2x minus 5 plus 0.803. Last types of problems here. Notice again, we're going to have to use u substitution when finding our antiderivative here to solve our differential equation. So that means we're going to get u, which is equal to 2x minus 1. So again, the derivative here is 2 times dx. So divide by 2. Now notice 1/2 here. So here we're going to find our integral, right, of dy here. So is equal to 1/2 times our integral of u squared with respect to u. So now here we end up with y, which is equal to, so this is u to the third, right, divided by 3, but times 1/2. So this is u, which was 2x minus 1 to the third, over 6 here, right, 1/6 plus c here. So now we'll substitute, right? Y is 0, which is equal to 2 times 1 minus 1 here, the third power over 6 plus c. We'll notice here that this is just 1 to the third power, which is 1. So 0 is equal to 1 over 6 plus c. So what does our constant have to be here to get us to 0? Negative 1/6. So that means here we've got y is equal to 1/6 times 2x minus 1 to the third minus 1/6. So now what if we have our trig function? Same thing. So here we go. So again, getting our integral here, our antiderivative. So again, notice we've got u substitution here. U is 4x. So now our derivative is 4 times dx. Divide by 4. Notice this is 1/4. Well, 1/4 of 8. 8 divided by 4 is 2. So we're going to find our integral of 2 times cosine of u with respect to u. And again, with respect to y. So y is equal to integral of cosine is sine. So 2 times sine of u, which is 4x plus c. So here we go. Y is negative 2. 2 times sine of 4 times pi over 8. Well, notice here that this simplifies to 2 times sine of here, because that's 4 and over 2, pi over 2 plus c. So now we can refer back to our circle or to our graph, right? So sine of pi over 2. That's how we end up with from our unit circle as well, right? That sine of pi over 2 here is 1. So that means here, negative 2 is equal to 2 times 1, which is just 2, plus c. So what does c have to be? Negative 4. So here, y is equal to 2 times sine of 4x minus 4. That is our equation here. So here, pause the video and try this one on your own. And here we go. So again, we're going to find our antiderivative here. So that means u was 5x. The derivative here is 5 times dx. So divide by 5 here. Now we're at 1/5 times du. Well, 1/5 times 10, or 10 divided by 5 is 2. So 2 times sine of u with respect to u. And again here with respect to y. So that means y is equal to the integral of 2, right? But times sine is negative cosine. So negative 2 times cosine of u, which is 5x plus c. So now y is 1, which is equal to negative 2 times cosine of 5 times pi over 5 plus c. So then here you should have noticed 5 divided by 5. So really you're just finding cosine of pi. Cosine of pi here is negative 1. So here I've got 1, which is equal to negative 2 times negative 1 here, right? Sorry. So negative 1 here, which is positive 2. So what does c have to be here? 2 plus what would get you 1? Negative, not negative 3, negative 1. So that means here, y is equal to negative 2 times cosine of 5x minus 1.